Okay, Mario once again with MIA Microflight, and this is my CNC machine done with a combination of steel rails. These are square tubing, steel square tubing, 1.5 inch, uh, with 3D printed parts. You can see all the green parts, all the yellow parts, the gray parts are 3D printed. And I just got done assembling this machine as far as you see it in this video here. I still need to put the the motor that drives this would be the x-axis, y, and this is a long table. I made it that way because I prefer to have it long versus the standard CNC routers that are typically long on the y-axis. This is short on the y-axis, long on the x-axis, and of course there's the axis up and down. But the frame, as far as the frame is concerned, is it's quite it's quite sturdy. It's not going anywhere, especially with this board here that I have to replace. This is the board that was on the MAXPATH 42 NC, which is the machine that I talked about in another video. These are the parts for that machine. I ended up taking that machine apart completely. It's an all aluminum machine, aluminum and steel rails with just Thompson pillow blocks and linear rails. This on that machine on the y-axis with dovetail rails on the x and y and z rather. So we can just take a look at the let's see this mess here. You can see this was the basically the X rail aluminum plate, quite beefy. I ended up modifying that machine a while back, about 10 years ago, maybe more, with these steel rods on top of the top and bottom surface, so that I can use the skateboard trucks, skateboard ball bearing trucks, as I'm using on this machine here, and so that I can get a little more precision, because that machine, after so much use, it got worn out on the dovetails, and so that was my modification at that time. But since that time, which is back in 2012, I stopped making the helicopter upgrades that I used to make. Quite a bit of that. That stuff was done on that machine. That's the MAXPATH 42. So it did serve its purpose for as long as that machine was in use. And then I just it was just sitting here in this cubby hole, and I showed that also in another video. If you want to look at that video and just kind of see what that machine looks like. If you're not familiar with a MAXPATH 42, that machine's probably maybe 25 years old. Good machine for the time. It was one of the first machines that came out in the $5,000 range for a 18 by 36 cutting area. So one of the reasons I got that machine is because of the cutting area, and I had a chance to go over that machine at the factory. I met the gentleman that used to run that company. He invited me over to check out the machine and gave me a demo, and I ended up buying that machine based on those details. So I used that machine, and like I was saying, I had to modify it, and then I stopped using the machine because I got into 3D printing, and all my products went into 3D printed parts. And as I talked in the other video, as I mentioned, I was going to revamp that machine. I was going to make it into a long, low-profile machine like this one here, but it's going to be a little more work than just doing it from scratch like I did this one. I already had this design a while back, years ago, but I never had the time to devote to the completion of this design, which was kind of lingering in my CAD file. And so I decided to just bite the bullet and just complete this machine. So this is what you're looking at. The machine almost in its full completion. As I was saying, the frame is pretty sturdy. The A arms right here are also pretty beefy. They encapsulate this 1.5 inch steel bar or tubing. This is 1/16 inch in thickness, so it's uh, it's a pretty sturdy tube. But for a CNC machine, I think I am going to maybe change these arms and go with steel, some steel arms, and change some of these components that I did in 3D print form. More than anything, I did these in 3D print form just to get an idea of what I could what the machine was going to look like, and as far as clearances and spacing requirements and all that. So it's not really parts that I would want to keep permanent on a CNC machine, because they do plastic is I don't care how how you reinforce plastic pieces, 3D printed parts, that there's just no comparison with steel or aluminum machine parts like these brackets here. You can see that these brackets are kind of similar, but I had to beef up those parts in the 3D printer form, so that I can get a little more, just more rigidity on the part. And these parts they're not totally 100% infilled, but they do have quite a very I think I infilled this with a 3 millimeter spacing cross hatch. It's one of the infills that is used for hexagon, with the triangles inside the hexagon. So it's pretty beefy part with that type of infill at about 30% infill. So they're doing the job for right now, and I don't think this is going to have any trouble cutting wood the way it is. However, if I want to cut materials that are a little bit stronger than wood, I do need to beef up or change these parts completely, because like I said, 3D printed parts are just not a match for aluminum or steel parts. Same thing with the A arms. These can probably stay, because the framing is well supported here, and it's going to be boxed in by this board right here. Once I get the proper size board, this is the board that was on the MAXPATH 42. So it's a 20. I believe this is 24 by 35 by 48. That was the actual dimensions of the machine, the outer perimeter of the base. The cutting surface on that machine on the MAXPATH 42 was 18 by 36. On this one, I can easily cut 48 inches by 18. So so it's a nice it's a good size machine. If you for cutting just cutting getting a 48 standard 48 by 96 board, cutting it in half, and or maybe thirds, and just putting those pieces here and then machine from there. So from that point of view, the machine's pretty sturdy, like I was saying, as far as the frame. But these arms are here, even though they're pretty beefy, and even with these brackets here, these are about 0.75 inch in thickness. This is 1.5 inch in thickness also, and this is done with 2 plates here. Not 2 plates. One plate is on the outside. That's the plate that supports the motor on the inside, and you can see my motors are all on the machines that I designed are all on the inside underneath these beams. They're not exposed. I don't like the motors exposed. It's 99.9% of the CNC routers out there are done, almost like with this motor outside. The axis here, and I did this just temporarily, but I think I'm going to bring this motor at the back and just run couple pulleys and a belt, to drive that, so that I can balance the weight a little bit better. Because when you have this mass here, this is one of the beefier Porter cables. I don't even know if they make these Porter cables anymore, because I haven't seen this. But I used to buy these at Home Depot. I used to go through these every year. I would buy a new one just to keep up with the stuff that I used to machine here. I used to machine quite a bit of composite materials. with the MAXPATH 42 and the Porter cable routers. In fact, the machine came with a Porter cable router, and that's how I just got stuck buying the same thing. And these Porter cables are pretty nice. For me, they work just fine. I did change the collet on this one and went with an this the collet that came with this machine, or the collets that come with these Porter cables, I believe they're a little bit different than this. This is an upgrade that I did. Although the collets, it's an old collet. It's been worn out, from all the abrasive stuff that I used to cut here with this machine, and this is still good. Even though I stopped, the last year that I used was 2012, and since then, like I said, I haven't used this machine when it was when this router was on this MAXPATH 42. So the yeah. So as far as the rigidity of the machine, I mean the machine is it's quite. I mean it's acceptable. It's not totally. I mean there's a little bit of flex here that it's bothering me, and one of the things that I did not want to do is and that goes against my own standards for rigidity is I was going to make this a dual rail, one tier and another one up, and then just split the load that way with a much higher bracket. So I decided, maybe I can just get away with one here if I introduce a very low profile and very close system here, so that the motor does not stick out too far out. And if I move this motor in the back, I can distribute the weight a little bit more evenly, almost saddle mount type system here. So that was my target, but considering that I've spent quite a bit of time already on this machine, I'm kind of eager to just get it going and finish. Connect the motors, to the control box. I do have a couple control boxes that I can use with the machine. So as far as that is concerned, at least I don't have to do anything with that because they're already assembled in the box, and all I have to do is just terminate the cables on the motors. I have to basically do the same thing here with these 5-pin DIN connectors. This one is I did this temporarily just to test the workings of the motor, and this like I said, I pulled this from a plasma cutter, another machine that I built. So I pulled these motors from there. I pulled the trucks from there, and I've been kind of reusing that here because I'll never use that plasma machine. So, and it's sitting outside. It was gathering dust, and so I decided to just bring these components here in my shop here. So that's where I'm at right here. Definitely, this system right here needs to be beefed up here. The 3D printed parts, like I was saying, they're okay, but and I doubt anybody that's building 3D printer routers with 3D printed parts, they're getting rigidity on their machines. I highly doubt that those machines are going to perform like a machine that's is built with it's built with steel components. So I am looking to change these. I will put some plates here, steel plates or aluminum, half inch aluminum would work just fine for the stuff that I'm going to do. I don't plan on cutting metals and things like that, so the machine does not need to be totally rigid. If I was going to machine aluminum here, I would make this obviously more rigid than that. But the machine as is will work just fine with wood. It's something like oak for cabinetry work. I would definitely change these parts, and then just go with something more beefier, because these will cut plywood and very light maple, not maple, but pine and stuff like that. When you start getting into hardwoods like oak, then you really need something a little more rigid. And but it's came up pretty decent. Consider it's a single rail machine, and Um, and I think it's because I'm keeping this very low right here. You know, my Z up and down is no more than I think I have 3 inches of travel here, which is all I need here because I don't plan on cutting wood that is too high or too thick. So most of the stuff that I'll be cutting here will probably be around, So that's about the at the lowest point of the machine here. This is actually the baseboard, and on top of this, I'm going to put a 1/2 inch spoil board here, like I used to have on the MAXPATH, and like typically all machines have spoil board. And on top of that, I'll be cutting my wood. So we're talking about something perhaps like that. Assuming that this is the actual piece that I'm going to cut. I got plenty clearance here, and if I need to go higher, I can go higher here as far as that is concerned. So if I have a 2 inch a bit here, I still have room here to do the cutting comfortably. So all this was figured out in CAD. I did have to. This was one of the rails that I did in 3D printer form, and it's kind of similar to that one. All these parts will work with this because these have these V edges here that stick out almost like. So I basically replace these metal ones. These are steel square tubing, 3/4 inch square tubing. For this because this was giving me a little too much flex on this part here, and when I went with these rails, steel rails, that I'm getting a little more rigidity there, even though, like I said, 3D printed parts, for the brackets and for some of these things, it's okay, but it's this could be done much better with steel or even aluminum pieces. So, but I think the machine will work just fine. So we're just gonna have to wait till I complete this machine. It's probably gonna take me another week to do this, and I'll be running some test cuts here and see how the machine performs. But so far, this is where I'm at. I'm pretty happy with the way this came out. It's very clean. The machine is like I said, the motors are hidden. The lead screws are hidden. I'm using lead screws here, four start lead screws, because that's what I use in some of the machines, and they work just fine, for the stuff that I'm going to be doing here. So, Mario, once again, stay tuned for more.